All right, I'd like to introduce our next presentation here at the Planet MicroCap Showcase Vancouver in association with Small Cap Discoveries. Now presenting is Patrick Blott from Intermap.
Hi everybody, Patrick Blott. I'm the CEO and Chairman of Intermap Technologies. Intermap is a geospatial intelligence company. I'll talk to you a little bit about what that means, what that is, what we do, what the products are that we sell. More importantly, I'll tell you about some of our customers, some of our use cases, what's gaining traction right now, and how we positioned the Intermap business model to really take advantage of an enormous growth opportunity in our industry. Before I get started, forward-looking statements. I will be sharing financials. I'll be sharing some outlook. Actual results may vary. Intermap. When customers think about Intermap, a couple of things that they know that is important to understand about our company. One, we operate in 3D. Everything we do is in 3D context. Number two, we operate at global scale. So Intermap is managing and delivering models and geospatial data anywhere on the planet at a scale that allows certain use cases, certain customers, particularly big ones, to solve global scale problems. Number three, we do that with an extremely high level of precision, right? 3D, global, precise data. If one of our customers pulls a point and they happen to need that geospatial data in Prague, they can pull the same point in Toronto or in Bogota or in Jakarta. It's precise data. It's a single elevation model. It's a very high grade 3D globally precise model. And then finally, the first half of this year we grew plus 50%. We expect both growth and profitability. We're profitable to continue and accelerate. What's driving that? The key change in our business model is our customers will tell you Intermap's offering geospatial data as a service. That is very transformative, not just for us, but in terms of how customers in the industry consume this data. If I go back 10 years, we would collect data. We'd send sensors and airplanes and different platforms to collect data. We'd argue with customers and potential customers about what the specifications of that data should be. These were very high-level conversations among very sophisticated geospatial users, often with PhDs, often working for governments. And today, we're selling points. We're selling points to professionals that are not geospatial experts. They're experts in what they do, but they don't need to be geospatial experts anymore. We have the software, the analytics, the applications, the ability to exploit and deliver this data so it's no longer sold as a geographic patch where maybe a couple of points were relevant, most of it was never used or seen again. Now our users consume data that they need, where they need it, only the data they need, and we expend our energy and our effort and our focus on maximizing the value of those points. It's not volume points that matter. It's get me the point that I need to solve my problem. That's a transformation in the business model. So Intermap, 3D, global, highly precise, and you can buy it as a service, so you don't need to be a PhD to use it. That's really important. The industry is generally divided in two customer segments, government, commercial. 2/3 of it is government, and it's likewise about 2/3 of our business. Company was founded in 1997. We have a headquarters in Denver. Our engineering team is in Calgary. Our software teams are in Czech Republic and in Jakarta. And we'll get into it a little bit more here. So I just told you a little bit about why we're generating the cash flow now. Very high margin when a customer can say, you know what, I'm going to use your infrastructure. I'm not going to duplicate it. I'm going to call points through an API. That's efficient for them, cost effective for them. It's super high margin for us because we're selling the same points over and over and over again out of archive. Intermap has one of the largest geospatial archives in the world. We maintain a global gold copy base map at a 1 meter post resolution, bare earth of the world and surface models, which means we have all the features on top of it as well. And this is an important asset, and we can sell it to these users in ways that allow us to sell them a solution to their problems, as opposed to saying, I want to sell you a data spec, or I want to sell you, even worse, I want to sell you a sensor. Let me tell you all about this super cool sensor that I put on an airplane that maybe it's a LiDAR or whatever. We don't have that conversation. Our conversation is, how do you estimate the risk premium you want to charge on this house if you want to insure against flood risk? That's the conversation we have. And we get them the fit-for-purpose data for the particular house, served to them as a service, and they pay a fortune for that. So that's important, and I think the financial results are starting to reflect why that's important. Right now, 60% of our business is recurring, repeating, high margin as a service revenue, and that's doubled just since the end of COVID. Intermap's traded on the Toronto Stock Exchange. Our longtime auditor is KPMG. I'm the largest shareholder with approximately 20% fully diluted. We're a 30 million or so market cap, and we're trading based on our guidance, just under 2 times revenue, just under 8 times EBITDA. We did 6 million last year. We're guiding for 16 million for calendar year 2024. This is a surface model. So this is elevation data. This is the 3D data we specialize in. Nobody who buys our data looks at our data. So we have this here for illustration so you can see it. They're buying the coordinates, the point coordinates that are used to represent in this image. Our users are taking data through API, and it's feeding directly into their workflows. Surface models are used for things like telecom planning. They're used for various commercial navigation at large scale use cases. This next model is a terrain model. It's the same model with all the surface features removed, whether they're man-made buildings, roads, or whether they're natural, trees, etc. And this model is really important if you want to underwrite flood, because the top roof of the house or the top of the trees aren't going to tell you much about where water vectors are going to flow if you're in the middle of a hurricane, right? This will. This is a very important model. The ability to generate a global high-resolution terrain model at precision is very, very hard. We have all kinds of proprietary technologies and proprietary algorithms and patents that support our ability to do this and to do it at scale. Just a quick example to anchor it for people who may not have as much knowledge, but the picture on the left is a satellite drape. So you take an image, picture from space, can be in any kind of sensor format, but this one here is an optical format, and it's draped over exquisite Intermap elevation data. And if you pick the 5th floor of any one of those buildings, I can tell you with precise coordinates where in space, where in the world it is. And same with all the features, it's a great visual representation. On the right side, your right side, that's using inferior elevation data. Same image, but if the elevation data has errors, or if it has very large point spacing, or it's not very good, you can't use it for very much, right? You certainly couldn't use that to navigate a drone, because you'd fly it right into the building. So elevation data matters, and you can see the difference in an example like this. This is another example. This is a real-life example. Black Rock Island, a couple of years ago, search and rescue helicopter in a storm at night, flew into that island on the top frame. It was flying instruments. Its onboard sensors and onboard data weren't good enough, and it crashed. Everybody died. And below is the same scene with Intermap data run through it. There's a 50-meter difference. So a 50-meter difference in a use case like flying a rescue helicopter in a storm is the difference between life and death. So this data really matters for certain things. Does it matter in a video game? Well, we supply video game customers when they want reality capture, If they want synthetic, it doesn't matter. Nobody's going to die, right? But it matters a lot if you're talking about real life, important military kind of situations. Governments use the data for base mapping. This is the foundation map. So if you have the ground and you have it right, all the other layers in the data stack, they line up correctly. There's ground truth. And to give you an example, our insurance underwriters will have upwards of 150 layers in forming their data stack to get the points and to get the numeric information they need. If the ground is wrong and it's kind of got error and it's shaking, as you go up the stack, that error magnifies exponentially, not linearly. So your top layers, which are often your most expensive and most important, are useless if your ground truth is off or it has significant error. So ground truth, ground layers, foundation maps, 3D, that's us. Same in terms of commercial applications. Our largest verticals are insurance, our transportation, navigation, and telecommunications. I'll talk about that. In terms of why we can do it, a couple of things. One, we do exploit and have for a long time AI, ML. That's part of our creation of the data stack. We're using NVIDIA advanced chips to do that. We can extract all kinds of features. We just announced a contract this week with the National Geospatial Intelligence Agency in the United States, and that's a feature extraction contract, again, global scale, pulling things like roads, buildings, rivers out of the base map and doing it very accurately, very quickly. We also have very important infrastructure around our base map. Like I said, it's the only commercial base map that's globally precise. That's a very core asset. That is, an irreplaceable asset. The technologies to ingest new data. On your right side, we're able to take imagery or elevation or other sensor data, incorporate it into our global model, and integrate it. We don't interpolate it. We don't patch it. We don't have a global model that has different sensors that contribute to it. We have a single base map with the relevant information integrated, and that's a very complicated and important and patented processing process that allows us to do that, allows us to do it really, really fast. We have a variety of use case patents. I've just listed a couple of them here. One of them is processing related, IRIS. We have patents in terms of how we get ground truth. We have sensors that can see through all company owned. They can see through all atmospheres. They can see through trees. They can see through all features. They can get right to the ground, and they can go through the ground if the use case requires it. We have patents for defining terrain models based on those sensors. We have patents for software that is called FloodScope that does global flood mapping, and we have patents for things like specific use cases. What are the first floor elevations of a structure? Well, Intermap owns that patent no matter what source data you're using to get there. Another example on the left, that's a satellite image from space. You can see the clouds, you can see the tops of the trees. You can't see much in terms of fencing or borders. On the right, that's one of our sensors. If I zoom in, you can count tree stumps. We are not obstructed by atmosphere. We work in very difficult environments like Indonesia, like Alaska, where there is lots of atmospheric difficulty. We see through trees and we penetrate the ground. We run algorithms that will count those tree stumps for you. We run land cover layers that will tell you what kinds of trees it is. And all this stuff is really useful information and data that we sell to both commercial and government customers. In terms of our as-a-service model, we're getting serious traction now. We just won a major contract with the government of Indonesia to refresh their foundation base map. The phase one of that is $20 million for the first calendar year. We're going to get about 55-60% complete of it by calendar year 2024. That's important because Intermap is starting from a $6 million revenue base. So, in the first half of this year, we booked over $5 million, and we're going to book half of that contract in the remainder of the year. So, we've also added several $1 million of insurance contracts. We have over 60 underwriters. They're using our data at the front end of their process to price risk premium. That's the most important part, because if you don't get that right, you're going to lose money. We also signed a very important contract with the world's largest space-based communications company. They're using our data in terms of their receiver network, which is a global business. It is not a city business. It's not a provincial or a state business. They're going to sell this around the world. It's going to be very disruptive. They need data to figure out where receivers go. They need mostly to understand signal propagation so that where signal will be received. The competitors, all of whom are incumbents, cell phone networks, if it's Toronto, it's Rogers and Bell. Well, they don't want their signal interfered with, and whether it is or it isn't, they're going to claim it is. So they need data to establish the signal interference. Our customers buying data for themselves, for their competitors, for the regulator. They got to make this case everywhere they go in the world to roll this thing out. So that's a really important customer win for us. And it's reflected in the financial performance. I think the other important thing to note here is our monthly recurring revenue now is $400,000 plus. That's a high double-digit grower. And importantly, when you sell the ability to use a useful point, the analytical layer, the software layer, and the data, it's extremely sticky. So our churn is sub 1% going back several years. It's sub 1% annually, which is probably 10, 15-fold your typical software company. And it's because not only are they getting the ability to use the point, but they're getting points they can't get anywhere else. It's very exquisite data. Indonesia, we announced the first 10% of the mapping. We're going to do Sulawesi, which is that wishbone right in the middle there. They've got to get the whole country done over the next 4 years, so stay tuned for more on that. We're spec'd in, and we have our sensors and assets and people deployed now. And again, very most importantly, this is a big contract. It's a large land area. It has a potential of plus 180 million of revenue for Intermap, which we're executing on. But they understand, and our customers understand, that the real benefit here is what do you do with the data once it's all built? Our customers who are underwriting in Europe and North America, the largest protection gaps in the world are in Southeast Asia. And they're not underwriting in Southeast Asia because the data's not good enough. I'm not telling the Indonesian government that. They're telling the Indonesian government that. So the Indonesian government is looking at this foundation map and they're saying, we need to be able to commercialize this data. We need it accessible both to our users, government users, but we need it accessible to commercial industry. And Indonesia is the second fastest growing country over the next 5 to 10 years in the world. It's got, I think, the largest working age population in the world. It is an extremely exciting place that is rising, and they want a lot of these consumer and commercial applications that get enabled by this data. So what they call the economic benefit is like in a typical government spend scenario might be 2 or 3 or 4 times a dollar invested, a dollar returned. In this scenario, it's more like 12 or 15 times a dollar invested versus the dollars they get out of it. Very, very important. And we're enabling it with application layers, which we expect to leave behind. So we're working in Malaysia. We're working in Colombia. We're working with USGS. I mentioned contract we just won with NGA. That's our 5th U.S. Department of Defense contract. We're a dual-use company. All of these capabilities I've talked to you about today are defense-regulated technology. We own it, but you can't copy it. You can't steal it. We can't use it for certain things. Everything we do is regulated by ITAR in the U.S., and it's regulated by controlled goods in Canada. That can be cumbersome, but it's a very powerful moat for our business. And in terms of underwriting, we have a software product tailored for Europe. That does a lot of reinsurance. In the U.S., it does a lot of premium underwriting. We're working with in partnerships with Ernst & Young and Royal Haskellning for climate risk modeling, and we have several financial institutions acquiring that. We're working with Lufthansa in an exclusive partnership. Jointly, we have the only data set, which is called NextView, which is certified by FAA and the SA for the commercial cockpit. That is a big deal in terms of navigation upgrade, but it's also a big deal in terms of beyond line of sight drones. We operate drones, only military, but for the commercial application, in terms of things like beyond line of sight package delivery, et cetera, our data is the best suited for that purpose. I talked about space communications. We also do rural broadband. We do things like alternative. We have several customers who are planning farms and renewable energy, and they use our data for the network planning. And I talked a little bit about defense. We're on 5 vehicles now, 3 with NGA, 2 of them with the U.S. Air Force. That's very important for 2 reasons. One, the U.S. Air Force is the single largest by a country mile consumer of geospatial data in the world. We're on their program of record, Advanced Battle Management System program. That's a $1 billion pipe. We're also, as a prime contractor, working with them on systems for GPS-denied navigation. That's a huge problem. It's another example of where this data is very fit for purpose in terms of alternative nav solutions, onboard nav solutions, autonomous nav solutions, solutions that don't rely on GPS. So with that, I will pause. If there's any time left, I am happy to answer a few questions. All right, so I will leave it there. Thank you for your time, everyone.